Hello everyone, my name is Fatemeh. I'm a postdoc at the University of Bergen, and I'm also involved in Digital Life Norway as a coordinator for data management. And today I'm gonna give you a short introduction about Digital Life Norway and some data management activities that we have done so far, or actually we are planning to do for the center. Yeah, I'm sorry for this. Yeah, so Digital Life Norway actually is a national center for biotechnology education, research, and innovation, and it was established during the spring 2016 and actually supported by the Norwegian Research Council. This one way. So this one?
That one, yeah.
No. So DLN actually potentiates the transdisciplinary aspect of Norwegian biotechnology by integration of life sciences with informatics, mathematics, and engineering. And actually it's hosted by three main universities of Norway: University of Bergen, University of Oslo, and the Norwegian University of Science and Technology. And some other universities and institutes such as SINTEF and UIT and MBU are also a part of Digital Life Norway. So this is the organization of the center. Yeah, I'm really sorry. This is the organization of the center, but in a very simple way. So DLN is organized into research projects, and DLN networking team, which are also organized into different working groups. There are a DLN board, and we also have 7 DLN scientific advisory board that they are also collaborating with each other quite a lot. DLN is currently involving 12 major projects, and as you might guess from the pictures or maybe the titles, these projects are covering a wide range of cross-disciplinary fields such as synthetic biology, system biology, mathematics, and bioinformatics. Therefore, they create different types of data. They need to store these data. They need to share this data between themselves and their collaborators inside or outside Norway, or they need to analyze this data. But of course, this is not always very easy. And as an example, I can use one project is a DECODE project, which is about decoding the system toxicology of Atlantic board. And the researchers in DECODE project actually were using Dropbox for sharing the data. But as the project was going on, they got a problem with the storage of the Dropbox, and they had to pay more in order to increase the storage. So this could be maybe a temporary solution, but imagine that DECODE project is a 4-year project, and then they need more robust solution for this. Another example, it's for a biofarm project. They already produce a lot of high-volume differonomics dataset, and they got also some challenges for storage and integration of these data. So it was only 2 examples, but if you actually look for all of the research projects, they have some questions in common. They wanted to know where they need to keep their data and how can they share their data between themselves, between the collaborators, and are there any tools or facilities for them that they can put their data, they store and actually share the data easily. So actually, we in DNN help research projects for the data management, and the active use of data management, of course, according to the FAIR principles, are highly supported and promoted in DLN. So we work to identify and support the well-functioning systems or tools that actually fits to most of the DLN projects. And towards this aim, we arrange and offer workshops to help researchers gain new skills in DM. So this is one of our main data management activities in DLN. And we already had 2 workshops. In our first workshop, actually, we gave very general strategy and overview about managing their research data, and actually asked each research project to mention their need and challenges when they encounter for managing their data. And after listening to them, actually we came up with the idea that 2 data management platforms, one of them is SICK, which is a platform for system biology, and the other one is NELS, which is a Norwegian infrastructure for life science, could be a good option for the majority of the DLM projects. And therefore, we actually support the use of SICK and NELS in DLM projects, and we already had our first hands-on session for SIG and NELS to just give them more information about this. So I'm not sure how many of you are familiar with SIG or NELS, but I just give a very brief introduction about this. So SIG is a web-based resource platform for managing and sharing the scientific research data, and especially for mathematical modeling. So it's very useful when you're working in a system biology field. You can also download it and use it locally. And the good thing for SIG is that you can put your metadata or maybe just a part of your data in SIG and then refer it to your local data in some other storage. And this is the structure of a SIG. So SIG has this kind of graphical aspect, which is based on the ISA format. It stands for Investigation Study Assays. And it's actually a framework for showing how experiments relate one to another. And SIG also provides several tools to implement the standards DM. And these are very useful when you're working in the system biology field. For example, COPASI is a software application for simulation and analysis of biochemical networks and their kinetics. And the other interesting thing is also Write Field, which is an online software tool for adding ontology term into an Excel spreadsheet. There's also JWS, which is a system biology tool for modification, construction, and like simulation of your kinetic models and the rest of it. So now I just move to NELS. So NELS is actually, it stands for Norwegian Infrastructure for Life Sciences inside Galaxy in Norway. And actually it's a Norwegian portal and it gives this opportunity for the Norwegian universities or users to put their data inside, and it's also free for them. The Galaxy is used for computing in NELS for the omics dataset, and there's also a store bioinfo in NELS that they give them this opportunity to store their data for long term, and it's also free. So at the moment in DLN, we are currently developing an integration of the two platforms that I mentioned, so SIG and NELS. So it has a lot of advantage for us. For example, it can facilitate the long-term storage for users, while this is not true for the SIG. So you cannot maybe put it for long-term, but you can use it NELS to put for long-term storage. And the other thing is that we can actually solve this storage of high-value omics data sets. So what we can do, we can put the metadata in SIG while referring to our raw data or maybe our omics data set in NELS. So this is what the end of my presentation, and I just wanted to acknowledge Inge Jonassen, who is the head of Competence and Infrastructure Work Group, Rune Klebe, the coordinator of Competence and Infrastructure Work Group, Shell and Kidane from NELS in Bergen, and Stuart and Finn from Manchester and from Fatemeh that they are helping us for these technical works. And thank you for your attention.
1 minute, 45 seconds left. Time for about 2 questions. Anyone?
What would you say are the challenges for like the day-to-day research that is connected to the network?
Mm-hmm.
What are the challenges that they face when they need to share their data from systems biology?
You mean for the...
Question to Mike so that it's on recording.
Yeah, so the challenges for the DLN networking program. So the problem that they mostly had is about the sharing the data. So they didn't know how to do this in a proper way, so like by email or by using Dropbox, which was not very good. And the other thing, they got a lot of problem for the storage of the high-value omics data set. So it's like a very big data, but they didn't know how to store it and actually how to share this data. So this was the main problem. So using data management is highly supported in DLM, but actually there is not a fixed data management plan. So some of the projects, they really don't need any data management because of the type of the data that they have. But the other one that they also need this data management is mostly related to system biology.